Thank you. Some of you may be wondering, why is it that we've had speakers all pretty much from a single point of view here? Over the years, for these international conferences on climate change, I have personally invited literally dozens of the most prominent spokespersons for the other side who believe that humans are causing an imminent global warming crisis to speak at our conference. I've reserved keynote spots for them. Had they accepted, we would have had at these conferences anywhere from a third to a half of the spots filled with folks with that point of view. And I certainly do everything I can to be friendly and cordial in my invitations. Over the years, despite all those invitations, only two people have accepted our offer. One is Dr. Scott Denning from Colorado State University. The other is my friend Tam Hunt at the University of California, Santa Barbara. For today's debate, Dr. Denning, who has spoken here before, has agreed to speak, and I'm proud to say that he is also a friend of mine, and I'm looking forward to hearing what he has to say. Indeed, I certainly have a point of view, and so does Dr. Denning, and they don't always meet. And Dr. Spencer has a point of view, and sometimes we differ as well. And the important thing is, no matter where you stand on the issue, to make sure you have an open mind, and you're always willing to look into ways you might be wrong, challenge yourself, and if you are, then adjust accordingly. And I know I've debated Dr. Denning twice myself, and I have learned things from his presentations, and things that I said, hey, you know what, you were right and I'm wrong. So I hope we can all do that, and I'm glad that we're able to have this debate today. So just a little note about the format. We're going to have each speaker give an opening statement of approximately 12 minutes. It's my understanding that they will be using PowerPoint for this. I'll call them up one at a time for the opening statement. Then after that, I will ask the speakers a couple of questions, and then I will invite them to ask each other a question, and then they will have closing. So we'll try and get some interactive juice going here. I will be a stickler on the time so that we can make it through, and I will announce as each speaker takes the microphone how much time he has. So let me please, first of all, introduce our first speaker who will be presenting the case that's more in line with the United Nations Intergovernmental Panel on Climate Change. Of course, if Dr. Denning is going to take different points of view, that's up to him, but by and large, he's giving that point of view based upon our debates in the past. Dr. Scott Denning is a professor of atmospheric science at Colorado State University. His research sponsors include the National Science Foundation, NASA, the U.S. Department of Energy, and the National Oceanic and Atmospheric Administration. He is also an editor for the Journal of Climate and a project scientist for the NASA Carbon Cycle Initiative. Dr. Denning is very frequently published in the peer-reviewed scientific literature regarding carbon dioxide-related topics. I would recite a list of those publications for you, but we do need to begin this debate by the end of the week. He is extensively published. He is a friend of mine. I'm proud to say he's a friend of mine. Dr. Scott Denning, you have 12 minutes to present your case. Thank you, Scott.
If we could have the slide, please. I appreciate the invitation, James, and it's really a wonderful opportunity to come here and speak with you. I have to say I'm disappointed that you don't get more mainstream scientists that come at your invitation to these things. I think more of us should do so. So James has asked me to present the warmest case, as you see up here, but I'm going to sneak something by him here. I'm actually going to tell you that I'm really a skeptic. I'm going to tell you that a skeptical scientist will look skeptically at claims of all kinds and look at evidence about it. So we're gonna try to dispel some common myths about climate here in the next 12 minutes. Common myths about climate, and I'm going to ask you to be skeptical. I'm going to ask you to be very skeptical about things like this. Climate is complicated. It's a complicated story. It's very technical. You're too dumb to understand it, so you have to ask the experts. Well, that's a bunch of hooey. Actually, that's not true. The concern about global warming is based on recent temperature trends. Have you heard these? Like 9 out of the 10 hottest years on record. You get the idea that if somebody could find some other cause for recent warming, we could quit worrying about CO2. Well, that's a myth, too. You should be skeptical about that. Finally, I want you to think about the myth that global warming is some kind of theory based on computer models. And I'm going to show you that it's not. The worst myth of all, really, is that if we stopped burning coal, we're going to freeze in the dark. These are myths, and I'm going to ask you to be very, very skeptical about these myths. All scientists should be skeptics, and I want you to be skeptical too. Global warming is based on common sense. It's not based on computer models, it's not based on recent temperatures, and it's not complicated. You're plenty smart enough to understand it with your own brains. You don't need experts. It's all about heat. Heat in, heat out. That's really the whole story. You know this to be true in your own experience. You know that the more heat you put in, the warmer it gets, the more heat that goes out, the colder it gets. When we talk about weather, we have to talk about heat coming in and out the sides. But when we talk about the whole planet, there are no sides. The heat can only get in and out the top. Do you ever wonder why day is warmer than night? You ever wonder why summer is warmer than winter? You ever notice that Miami is warmer than Minneapolis? Perhaps you have. And I think if you just think about your own experience, you know why this is. It's not rocket science. It's very simple. It's all about heat in and heat out. There's more heat in during the day than goes out, so it warms up. There's more heat coming in the summer than goes out, so it warms up. There's more heat coming into Miami in a year than there is in Minneapolis in a year, so it's warmer there. Now, there's another misconception we have to talk about here, which is the difference between weather and climate. There is a difference. They're not the same thing. You can't look out the window and tell me what the climate change is today, because it involves longer periods than that. I don't know about where you live, but where I live, we know how to finish this sentence. If you don't like the weather, hey, you guys know that one too. You just wait 5 minutes. But if you don't like the climate, move. Because climate is actually not about the weather today. Climate is about location. More than anything, climate depends on where you live. Climate depends on latitude. That's why Miami is warmer than Minneapolis. It depends on altitude. That's why Vail is colder than Denver. Climate actually changes very, very slowly. And again, we know this. If you've traveled around our great country, if you've traveled around the world, you know what to expect of a climate in another part of the world. And it doesn't just change randomly from day to day. It changes systematically for very well understood and very simple reasons that every one of you understands just fine. It's very predictable. We know. You want to watch me make a climate prediction? It'll be colder in this city 6 months from now than it is today. That's climate prediction, and it's based on a difference in the amount of energy coming down from the sky 6 months from now that's very predictable. If I can predict a change in the energy coming down from the sky, which I can predict a change in the climate here in Washington, D.C. I did it. I'm batting 1,000. I do this every year. We can predict that Miami is warmer than Minneapolis for precisely the same reasons that we can predict a warmer future under CO2. Climate is really about location, location, location. So, you know, you've probably seen me, maybe some of you have seen me, I know James has seen me do this thing before. The heat going out of the Earth gets blocked by molecules of air. The O2 and N2 molecules that make up 99% of the molecules of our air can vibrate back and forth on their bonds and absorb some of that outgoing energy and then unvibrate or slow down and give it back. So you sort of imagine a molecule going woo when it absorbs some energy and then woo, woo, whoa, 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 back down. But CO2 molecules and water vapor molecules are different because they have 3 atoms in them instead of 2. Because they have the third atom, they can vibrate in different ways. Just like an O2 and N2, let's see, I only got 2 hands, so this can be the C and these are the O's. I can go woo, 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 whoa, whoa, whoa. But wait, there's more. The CO2 can also go woo, boo, 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 or bip, boo, bip, boo, bip. So it's got all of these different kind of wiggles that it can do. And each one of these wiggles will absorb a different wavelength of energy. That's why these are effective greenhouse molecules. They absorb energy, they emit energy, and this is extremely well understood. In fact, the measurement of the CO2 emission of energy was first made in 1863 by James Tyndall during the American Civil War. If you double the amount of these heat-emitting molecules in the atmosphere, it'll release 4 watts of extra energy in every square meter of the planet for 24 hours a day, 365 days of the year for the rest of your life. That would warm the surface. Let's consider a puzzle about energy. Differences in the amount of energy coming out of the sky in watts per square meter. Everybody knows what a watt is. You remember 100-watt light bulbs from back in the old days. Day versus night in Washington, D.C., about 500 watts difference per square meter. Summer versus winter around here, about 150 watts per square meter difference. Miami versus Minneapolis in January. You ever been in Minneapolis in January? Miami gets 75 extra watts per square meter. Those watts make a big difference. The Ice Age, the last Ice Age versus today, about 7.5 watts per square meter difference between the global Ice Age with a mile-thick ice over Manhattan and today. So how come the climate differences are biggest in the Ice Age with this mile-thick ice sheet for 7.5 watts per square meter and less for day versus night? How come we don't have giant ice sheets growing every night when the difference in the energy is 100 times greater? Why is that? Duration. The longer you leave the lights on, the more it warms up. At night, we only get dark for a few hours. In the summertime, we get warm for months at a time. The Ice Age kept that 7.5 watts per square meter for a long, long time. Let's restore the scientific method. Do you remember the scientific method from your high school days? You start with observations. You develop some hypotheses to try to explain those observations, and then you do some experiments. But you're not trying to confirm a hypothesis. You're trying to falsify a hypothesis. Science is all about rejecting hypotheses. The way that science works is that hypotheses can never, ever, ever be proven. There's no such thing as proving something right in science. There's only proving something wrong, and that's how we progress. That's how we make progress. So here's a hypothesis. CO2 doesn't emit heat any more than any other gas in the atmosphere. Rejected, disproven, easily rejected. In 1863, the amount of heat coming out of CO2 molecules was measured, and it's since then been measured thousands and thousands of times. Anybody in the world can make this measurement in the correct kind of laboratory. They'll all get precisely the same result, and doubling the CO2 will add 4 watts to every square meter of the planet's surface. If you don't believe that's going to warm up, I don't know why. You have to explain why. But the hypothesis that CO2 does not emit heat is rejected by measurements. Let's consider another hypothesis. Adding heat to the Earth's surface doesn't warm it up. Disproven. Look out the window. We know that adding heat to the Earth's surface warms it up. We see this every day versus night. We see it every summer versus winter. We see that Miami is always warmer every year than Minneapolis. Not just sometimes, every time. The Little Ice Age and the medieval warm period had about 1 extra watt per square meter compared to today. And they are different than today. And they had different climates. The Ice Age, the full-blown big Ice Age, had 7.5 watts per square meter difference. It's rejected. We know that the climate changes when we add or subtract heat. Here's another one. The extra watts of heat from CO2 will somehow be canceled out by something, right? Something's going to come along and get rid of that extra 4 watts per square meter. This is not disproven yet. I'll buy it. I'll buy that it might happen. For example, the sun could dim spontaneously by 4 watts per square meter right away. Better get going. Better start. Hasn't happened before, but it could. We don't know that it won't. Interplanetary dust clouds could get between here and the sun and reflect that sun back out to space. It could happen. Fog. We could have fog everywhere and it reflect the sun back out to space. These things could happen. We have not disproven the hypothesis that the extra 4 watts will go away. But I'm skeptical. I ask you to be skeptical too. Nothing can ever be proven in science, but scientists are skeptical people. Okay, I'm going to sit down and give it up to Professor Spencer now.
Well, Scott, before I introduce Dr. Spencer, I just want to say that I wish you'd take those woo-woos out of your presentation because My oldest daughter started middle school this past year, and now every time she sees a boy, I'm hearing that, and it's not good. It's all I can think about when you're up there. It's 1:15. What's she doing at home right now? Who's she on the phone with? Anyway, thank you so much, Dr. Denning. Our next presenter is Dr. Roy Spencer. Dr. Spencer is a principal research scientist at the University of Alabama in Huntsville. He was a senior scientist for climate studies at NASA's Marshall Space Flight Center, where he and Dr. John Christie received NASA's Exceptional Scientific Achievement Medal for their global temperature monitoring work with satellites. Dr. Spencer's work with NASA continues as the U.S. science team leader for the Advanced Microwave Scanning Radiometer flying on NASA's Aqua satellite. Dr. Spencer's research has been entirely supported by U.S. government agencies, NASA, NOAA, and the Department of Energy. He has never been asked by any oil company to perform any kind of service, not even ExxonMobil. Dr. Roy Spencer.
But I'm still open to the possibility, so if there's anyone from ExxonMobil here, I've got a bank account and routing number available for you. Okay, well, first of all, I got to say I agree with most of what Scott just said. Scott's basic message was that adding CO2 to the atmosphere does cause the climate system to not cool as efficiently as it normally does, and that it should lead to some warming. That I agree with. I know there's some scientists out there that don't think there's a global warming issue at all because the CO2 effect is saturated, or CO2 can't be a greenhouse gas, or the greenhouse effect doesn't actually exist. You know, there's all kinds of theories out there. For the most part, I agree with the IPCC, okay, that adding CO2 to the atmosphere should cause some warming. Where we differ is the degree of warming, because depending on how the climate system responds, it can be anywhere from Al Gore's Armageddon to, what's the difference? I mean, mankind is just one more source of variability in the climate system along with everything else. Okay, first of all, I want to point out that there's no official skeptics view on global warming. We have a lot of different opinions. We don't take votes. We don't try to form consensus. Also, what follows is my interpretation. I can't represent all the skeptics in 12 minutes, and I'm not going to try to. So I'm going to give you my view of the way the climate system works. And this is consistent with one of Scott's messages that he just gave. This is a quote from Albert Einstein. "No amount of experimentation can ever prove me right. A single experiment can prove me wrong." And I agree with Scott that not only should we be skeptic of the IPCC's views, we need to be skeptical of some of the views that we have. But the thing I like to point out is, despite the fact that there are many views, alternative views, of what has caused climate change, it only takes one of us to be right for the IPCC to be wrong. Okay, possible explanations for global warming. There's really only two major classes here. Humanity's greenhouse gas emissions, by far, has got to be the biggest forcing mechanism. The IPCC, that's their view, and I agree with them. The other one, which they are virtually ignoring, are natural forcings. In other words, climate change does not require us to upset the balance of nature. Nature routinely upsets its own balance anyway, okay? And of course, it could be some of both. This is where I fall, is I think the warming we've seen in the last 30, 40 years is some part natural, some part anthropogenic. If I had to guess, I would guess it's mostly natural, but I don't think we have a clue how much is anthropogenic. Now, what's interesting is that the public doesn't realize that the government has funded virtually no research into natural sources of climate change. Okay, virtually none. But even if warming has been anthropogenic, is it anything that we need to be concerned about? All right, first of all, here is a part of climate history that the IPCC has been trying to expunge for years now, which is the fact that over the last 2,000 years, global warming and global cooling in just about any century has been the rule, not the exception. It was much warmer for centuries at the time of the Vikings farming in Greenland. There was a little ice age. The IPCC claims these events were only regional. Regional and lasting for hundreds of years? Oh, really? And yet the IPCC claims that a single summer in France, 2003, a heat wave, has global significance? I mean, you can't have it both ways. And if you'll look here, that red curve there at the end is the only thing that could be explained in terms of increasing CO2, okay? That little red area, the last 50 years, that's really the only warming that could be caused by increasing CO2, because we really didn't increase CO2 in the atmosphere much until after World War II. Okay, this is going to be similar to what Scott showed, except he left something out. Warming of the climate system, and again, the ocean is going to dominate the long-term climate change because it can hold so much heat for such a long period of time. There's a forcing, what Scott was talking about, for instance, that 4 watts per square meter if you double CO2, which could occur late in the century. The forcing should cause a warming tendency, but in response, there is a feedback response. The climate system pushes back. If the Earth warms up, it gives off more infrared to space and naturally cools itself. The argument is over the degree to which the Earth does that. The IPCC believes that there are changes in clouds, things called feedbacks, that occur, which will reduce that natural tendency for the Earth to cool itself. Some of us think that the climate system behaves in such a way to enhance it. The difference between those two, again, is the difference between Al Gore's Armageddon and global warming just being lost in the noise of natural variability. Man-made global warming, I'm sorry. And then there's a big uncertainty here. Everyone agrees, deep ocean mixing. The more heat, extra heat is mixed down into the ocean, the slower the surface warming will occur. And so it's really important to know what the ocean mixing, how that plays into explaining the warming we've seen for the last, say, 40 years. Okay, feedback. This is the holy grail of climate research. This is the view of several of us. The IPCC thinks climate sensitivity is high. Scott mentioned that the ice ages were caused by only 7-watt swing in the global radiative balance. I don't think we have a clue of what caused the ice ages. I don't think we know what controlled the climate system hundreds of thousands of years ago, where we have no data and can only infer some things. Yet today we have NASA satellites, one of which I'm a principal investigator on, which cover the whole Earth every day. And we're still trying to figure out how the climate system works. And yet we think we know how the climate system worked 100,000 years ago? I don't think so. Okay, some of us have published papers which suggests that climate sensitivity is very low. Dick Lindzen, myself, David Douglas, probably a few others. That would be good for humanity. This plot is very important. I'm sorry to show a graph, but I have to do it. Okay, this shows the warming profile in the upper ocean in the last 40 years. In fact, the red curve on there and the green curve, the solid red and the solid green curves, actually are data from the IPCC report. Okay, so this is their representation of agreement, which shows, yeah, the observations show that the most warming has been, see up there at the top, that's at the surface, and then decreased warming with depth down to 700 meters depth. Now, they showed this PCM1 model in the report also. Now, they claim that this is agreement. What's interesting is that the observations show a whole lot less warming. In other words, the area to the left of those curves, all the way over to the vertical line, the axis, that shows how much heat has been stored in the ocean, extra heat, in the last 40 years. They picked a climate model which is less sensitive than their projected range of warming for the future. In other words, it's totally unrepresentative, and it still shows too much warming. I've fit the data to a simple forcing feedback diffusion model because those are the only 3 basic processes that control how much warming there will be in response to a forcing, like from doubling CO2. I can replicate what that fancy model does with a forcing feedback diffusion model. That's the dashed line. And in order to make the model explain the observations, that red line, I have to reduce the climate sensitivity down to 1.3 degrees. If climate sensitivity is only 1.3 degrees, we have nothing to worry about. Okay, this has been shown before in a couple of presentations today, which basically shows, James Hansen, of course, brought the whole global warming issue into the public's consciousness in 1988 in his Senate testimony for Al Gore. And he actually now has predictions from the past that can be validated today because it's now over 20 years later. Anyway, his red curve there, the one that shows the most warming for the future, that was assuming CO2 emissions, which is actually less than what we're emitting today. And then the observations there show what's actually happened. It's getting harder and harder for the IPCC to explain why it hasn't warmed as much as their models suggest it should have. Okay, now if recent warming has been partially natural, then climate sensitivity will be even lower. That 1.3 degrees that I showed that I got from the diffusion model as an estimate of climate sensitivity, which is really low, that was assuming James Hansen's forcings that he forces his models with. I just assumed that he's right, that we're basically the only ones forcing the climate system. But if there are natural sources of forcing, for instance, indirect solar forcing from cosmic rays, this is something I've always been skeptical about. Scott's right, we should be skeptical of everything, until I took 10 years of our best radiative budget data and found that indeed, in the years, generally speaking, in the years that more cosmic rays have been coming through to the Earth's surface, there has been an extra loss of radiation to space, which suggests more clouds, which supports the hypothesis. Now, it could be just by accident, but that's 10 years of global data where the satellites are covering the Earth every day. This is where I think most global warming has originated from, which is just natural climate cycles. There can be chaos in the climate system. We all agree, the IPCC agrees. Chaos in the atmosphere is there, and it prevents us from forecasting weather out 5 or 10 days. But the climate system in the ocean is just as chaotic, except it has time scales of hundreds of years, decades, hundreds of years, thousands of years. So climate change, as what we call climate change, could mean mostly just chaotic variations in the system. Pacific Decadal Oscillation is an example. I know I'm just about out of time. This plot right here actually proves from yearly average data, 1950 to 1910, that changes in the Pacific Decadal Oscillation, a known natural mode of variability, lead to global temperature changes years later. This is something the IPCC models do not account for. And then finally, Anthony Watts and others are saying, maybe warming hasn't been as much as we've measured because of spurious influences, because it's hard to get long-term good temperature measurements because the measurement systems change over time. So in that case, climate sensitivity could be even lower than that 1.3 degrees. So the bottom line is, I think that the public and the policymakers have been misled about not only the severity of the human influence on the climate system, but our confidence in how much humans affect climate. And that truly objective scientists, you almost never find this in the scientific community, should consider the possibility that maybe putting more CO2 in the atmosphere is actually a good thing for life on Earth. After all, life on Earth depends on CO2, and considering that, it's amazing that there is so little of it in the atmosphere. And I'll finish there.
And stay up here. I'll invite Dr. Denning to come up and join Dr. Spencer and take your respective podiums. And I will ask a couple of questions, and I'll ask a question. You'll each have 2 minutes to answer. So my first question is, there seems to be a general agreement among scientists on both sides of the issue that if you say double the amount of carbon dioxide in the atmosphere, that we'd be looking at, all other things being equal, a little more than 1 degree Celsius of warming. So my question is, what other factors? We often hear humidity, cloud cover, are or are not factoring in today, because most of the models from the United Nations derive most of their warming from those other factors that carbon dioxide is supposed to increase. So what other factors are occurring? What is the evidence that these factors may or may not be complying with UN predictions? Start with Dr. Denning.
So thank you for the question. I guess the Roy's talk pointed out the idea that there are these feedback processes, that you add the CO2, it adds the 4 watts. That's not enough to give you more than about a degree of warming. Other things have to happen in order for you to get, say, 3 degrees of warming for a doubling of CO2. The main thing that happens is that extra energy coming down from the sky evaporates water out of the oceans. And water is a more powerful greenhouse gas than CO2. I guess James doesn't want me to do the molecule dances anymore, but I just can't help it. What can I do? So the CO2 does this thing, but the water vapor does this one, you know? The water vapor's got these wonderful different dance moves.
How can I compete with this? I can't compete with this.
That allows the water vapor to emit even more watts down. The other one that people are familiar with that probably first comes to your mind is albedo, is the ice and snow. Where I live, it doesn't snow all that much. You'd be surprised in Colorado. It's a dry climate. We occasionally will get a snowstorm at Christmas time, and the whole winter will be cold because of that, because that snow will reflect sunlight out to space. It locks the temperature in at no greater than freezing, and it'll stay cold. If you melt that snow and ice, the ground is darker, can soak up some more sunlight, and allows the temperature to go up. So if you have extra water vapor in the atmosphere because of the extra evaporation out of the oceans, then you'll have extra downward radiation surface and warm you up. And if you have less snow and ice on the planet, you'll get warmer because it's darker. So what's the evidence of those? Basically, the evidence is that the climate has changed in the past. The climate, there's no question, even though correctly so, Dr. Spencer says, we don't know exactly how climate changed in the past, but we have some pretty good evidence that it did change in the past. We know that there were ice ages. We know there was a medieval warm period. We know there was a little ice age. We can actually do pretty darn well at telling you what the difference in the radiation was. And the real world, the real climate, changes by a few degrees for a few watts per square meter of change, and it has over hundreds of thousands of years. That's really the evidence.
Okay, thank you. Dr. Spencer.
Well, that's one of the troubles with climate sensitivity debates, is it's how much warming do you get for a certain forcing? Scott has already introduced that. How much warming do you get for a certain forcing? Trouble is, we can measure temperature changes through history a lot better than we can measure forcing. Okay? We have no clue what caused the medieval warm period and the Little Ice Age. I mean, people just don't talk about them.
He and I do.
Oh. We don't have any idea what caused them. So it's a human tendency to say, well, it was probably something small. And the problem is, ultimately, what you're talking about is climate change resulting from nothing, which means an infinitely sensitive climate system. This is a problem we run into with arguments over climate change. We know temperature changes a lot better than we know the forcings that cause them. And if we don't know what forcings cause them, it gives the illusion of a sensitive climate system. This is something that I've published on before. We now have a new paper that's been conditionally accepted for publication, where we show that the way that the climate models lose energy due to these feedbacks, water vapor and clouds, the climate models, none of them, either the sensitive or insensitive ones, show as much cooling, radiant cooling, whether it's reflected sunlight or whatever, when the Earth naturally cools from one year to the next, okay, that none of the climate systems show, or climate models, show the strength of radiant cooling as the observations do. We now have 10 years of daily observations of the radiative budget of the Earth. And it's clear there's a huge disconnect between the way the real atmosphere works and the way the climate models work. And I think it's because the climate models have positive feedbacks, especially in clouds, where they should have negative feedbacks.
Now, for the second question, I'll start with Dr. Spencer first this time. As we're discussing and debating the sensitivity of the climate, we've talked about feedbacks. There are also assertions that natural factors are playing a significant role, and then assertions that natural factors are playing a minimal role in recent temperature change. I know that you, Dr. Spencer, have published work regarding ocean cycles and clouds. We have other speakers that will be speaking, talking about the role of the sun. So for both of you, what I'd like you to address is whether it's through natural cycles or differences in feedback expectations, what amount of temperature change in what time frame would be sufficient for you, Dr. Spencer, to change your mind and admit that the climate is much more sensitive to carbon dioxide than you expected? And Dr. Denning, afterwards, how little or how much absence of heat over what period of time would have you change your mind as well? So, okay. Dr. Spencer.
Ooh, that's a tough one to answer, but I'll stick my neck out and I'll come up with some sort of answer in the next 30 seconds. I'll pull it out of thin air, along with the vibrating molecules. We already know that warming basically stopped at least 7-8 years ago, something like that, which is really weird. I mean, in the past, we've seen periods of no change. The difference today is that we have all this extra CO2. In other words, there should be, this should be a period of maximum warming, and the warming stopped. Why? Okay, so to answer the question, if warming resumes, James, in the near future, the next year or two, and continues at the rate that it did the last 30 years, if it starts doing that year after year after year, I'm going to start questioning my views on climate sensitivity.
Dr. Denning.
Fair enough. I have to agree that this is a tough one. And really the reason why it's hard, the reason why both Dr. Spencer and I are going to have problems with this is because climate changes slowly. The year-to-year variability is in the chaos, in the noise, and so you just can't tell from one year to the next whether there's a lot of global warming or not very much global warming. This climate sensitivity is a long-term number. So I guess I'm gonna pretty much just agree straight out with Professor Spencer's answer that, as you said, if over the next 30 years the climate warms just like it did the last 30 years, he might start questioning his views. If it doesn't, I'll question mine.
Fair enough.
Fair enough.
Okay, at this point in time, each of our presenters will be allowed to ask a question of the other. So you'll have 1 minute or less to ask your question and 3 minutes to answer. So Dr. Denning, I'll allow you to go first and ask Dr. Spencer a question.
All right. I actually have my question on a slide. Can you put my question up? There you go. So you don't need to read it, but you're welcome to read it if you like. Basically, the rise in CO2 over the last century, the 20th century, was about 30%. We went from about 300 ppm at 1900 to 385. This morning, Professor Michael's talk showed that Chinese emissions are actually much higher than the U.S., which is now true. There are almost 10 times as many people in China and India put together than in the U.S. Not quite, but it's getting there. And their economies, even in this day and age, are growing better than 10% a year. They're doing double-digit GDP growth year after year. So the question is, if China and India successfully industrialize their economies with coal over the next couple of generations, which is certainly their plan, by what percentage do you think CO2 will increase in the 21st century?
Well, I think what you're really asking me is, at what point do I think that more CO2 is going to be a problem as we keep adding?
How much more CO2 are we going to get?
Well, I think that we should, on the current track, we should double CO2. Right now, we're supposedly close to like 40% towards doubling compared to pre-industrial times, right? And on current trends, I think we'll double sometime after 2050, won't we?
Maybe so. I mean, I'm asking you.
All right, so we'll probably double. And that's the climate sensitivity number we've been talking about, is what happens, ultimately as a result of doubling CO2. Keeping in mind that even if we double at 2050, in 2050, it's going to take further time for the system to warm because the oceans slow everything up, okay? I think that we have no clue what our technologies will be in 2050. In fact, I think since R&D in energy development requires extra wealth to be generated, one could argue from an economic point of view, we should be burning fossil fuels like gangbusters to generate as much wealth as we can, divert some of that into alternative energy research, and we might get to those alternative energies faster than if we starve poor people and ruin the world's economies and reduce CO2 emissions.
Okay, Dr. Spencer, you're up with a question.
Scott was very well prepared with a question for me. I honestly couldn't think of a question for Scott. I know he's a fair guy, and I'm not going to be unfair to him by asking an unfair question. I think Scott does not represent the IPCC's position. Okay? Which is considerably more alarmist. I find Scott to be much more realistic in his appraisal of climate risks, and that we agree on most things in this debate.
Okay.
That was a softball if I ever heard one.
Now, as we agreed, you owe me two beers.
All right, well, we'll have 5 minutes apiece for closing statements. We'll begin with Dr. Denning.
Okay, could I have my slide again? So it was awfully nice of what you just said, Roy, and I hate to do this to you then. So let me wrap up.
It's okay, I'm used to it.
Yeah. So I'm coming back to my common sense here. If you had 4 watts, there's no question about the 4 watts. You know, this is a measurement issue. It's a repeatable measurement. It's easy to do. 4 watts on every square meter. If we double the CO2 by 2050, as Professor Spencer says, that's an extra light bulb on every square meter of the planet 24/7 for the rest of your life. Doing that would make the surface warmer. We can argue about how much warmer. And it was known before light bulbs were invented. This was not invented by Jim Hansen. It was not invented by Al Gore. The first measurement with this guy, John Tyndall, in 1863. The measurements have been repeated thousands of times. There's just no controversy about this 4 watts business. So how much warmer are we talking about? I'm gonna put a scary graph up here, and I made it up. I'll admit this. I made this up. This is a what if. Okay, this is not the IPCC. This is not some climate model. This is a box model, similar in spirit to the kind of models that Roy Spencer uses. If China and India industrialize with coal and successfully come to a first world kind of standard of living in this century, we won't be at twice in pre-industrial CO2. We'll be at 4 times pre-industrial CO2 by the end of the century. That's a big if. As Roy said, and correctly so, we don't really know what the technology is going to be. Maybe they'll wind up inventing fusion and selling it to us. I don't know. But it is possible. The other thing that is certainly true is that the extra CO2 will last in the air for centuries. My research is about where the CO2 goes, and some of it dissolves into the oceans, and some of it goes into the land. But accounting for all that, a big chunk of the CO2 stays in the air for many centuries after the fossil fuels emissions are done. So you see here on the bottom, you are here, we've had a little bit of CO2 increase. We'll in this century hit a very, very large amount of emissions if the other 3 billion people in the world that don't burn fuel start burning it gangbusters. And then we'll stop, because we'll either run out of the stuff or we'll invent something else. But the CO2 will stay in the air. And it will stay in the air for a long, long time. And absolutely correct, Professor Spencer says we don't really know what the sensitivity is. My reading of the paleoclimate record is 3 degrees for 4 watts per square meter is about middle of the road. You could say it's half of that. I don't think you could say it's a quarter of that. But if that were the case, you'd get about 6 degrees of warming, and it would stay that warm. It's not going to go back down when we move to another kind of fuel. It's there pretty much for good. The heck with polar bears. Think of your 401k. So what is 6 degrees Celsius warming look like? This is a map of average high temperatures in the United States. And each color is 5 degrees Fahrenheit. 6 degrees Celsius is about 10 degrees Fahrenheit. If you warmed the climate by 10 degrees Fahrenheit, that's actually quite a bit. It doesn't sound like much when you say it's 3 degrees. But when it's 10 degrees Fahrenheit, you're talking Wichita has the climate of Houston, or Chicago has the climate of Memphis, or Washington, D.C. has the climate of Tallahassee. Now, like I said, forget the polar bears. What's that going to do to the value of your home? What's that going to do to your 401k? This is not a small deal here. This is not guaranteed, but it's also kind of a big deal. The worst myth of all is that without the subsidy of cheap fossil fuel, civilization will crumble, will freeze in the dark, will starve. The sky is falling. You've heard it. I've heard it here. I've heard it here in this room. Be skeptical. Be very skeptical. My view is that's a pathetic way of looking at history. Maybe anti-American naysayers have never heard of capitalism, the magic of markets, the creative genius of a free people. Do you really think entrepreneurs will sit and shiver in a post-fossil world? I don't buy it. In my opinion, the people who tell you that modern wealth is due to the subsidy of cheap fossil fuel are wrong. They're telling you that if we stop burning coal, we'll freeze in the dark. I much prefer to believe that modern wealth results from the ingenuity and hard work of a free people, and that before we run out of oil, we'll invent the technology of the energy for the 21st century, and that our future is bright. Join me.
Instead of a closing statement, I guess I'll make my closing statement more respond to what Scott just said. I'm not sure where Scott's coming from, because that last soundbite there I agree with. I do think that free markets are going to solve this problem. But free markets are not the government taking increasing amounts of money and deciding what should be invented when. You know, energy. One reason why ExxonMobil, at least in good times, makes so much money is because everyone needs energy. You know, we need energy for everything we do. There's already a huge financial incentive to find new competitive energy technologies. I believe in the free market, as does Scott, to accomplish that, and I think it's going to happen. I think there are potential solutions in the long term. I don't think we'll ever reach not only 4 times CO2. I don't think we'll reach 3 times atmospheric CO2. We may not reach double atmospheric CO2, but we probably will. Because I think technology is going to come along and we'll reduce our CO2 emissions. Now, I further think that the global warming concerns will gradually go away as a lack of warming ensues in coming years. You know, that will pretty much kill the whole thing. But, you know, as long as we're talking about hypotheticals, you know, there is an asteroid out there that could theoretically hit your house, Scott. And I think you really should at least plan for the future and, you know, do something about that possibility. My point is that everything we do involves risks and benefits. Every decision a human makes involves risks and benefits, including lifting your fork and eating lunch, you know, because you may die from choking to death. You know, everything's risks versus benefits. And the thing that annoys me the most about those who complain about the potential risks of fossil fuels is they do it from such a comfortable position of benefits, you know. We had the tornadoes here a month or so ago in North Alabama. We were lucky. I don't think I lost a twig in my yard. But most of North Alabama did lose their electricity. And when you go for days without electricity, you realize this is a state you do not want to live in, you know. And yet, over 1 billion people in the world still live that way, without electricity. I'm in favor of them having access to electricity. And for those that are ultimately concerned about population growth, they should agree with me, because it's only the poor nations of the world that cause population growth in the world. If we can bring everyone into the 21st century, population growth will be reduced probably close to 0. And that's the ultimate concern, I think, of most environmentalists, at least the more radical ones, is that the Earth can't carry this many people, which I think is wrong, but obviously there is an upper limit. Well, you know, if you want to keep the Earth from getting populated by too many people, if there is such a thing, then encourage other nations to become prosperous as well.
Thank you, Dr. Denning. Dr. Spencer, please a round of applause for both of our presenters. Just speaking from a personal note, the 2 prior times that I'd seen Dr. Denning debate, it was when I was in the crosshairs on the other side. So you can see why I got my figurative big brother to take him on this time. So thank you, Dr. Spencer. Very importantly, excuse me? Are we going to have Q&A? We have time for Q&A from the audience? Fantastic. We'll do that, and then I'll give some wrap-up remarks. Are both Dr. Denny and Dr. Spencer okay with question and answer? Because I didn't put that in the plans. Come on up then. Wonderful. We have time for that.
Somebody just handed me a microphone. Roy.
Yeah, where?
This question right here. Your buddy.
Oh, hey, Pat. How you doing?
You made a statement about you would be concerned if the Earth resumed warming at the rate it did from basically 1970, from the mid-1970s through now, if you draw a straight line, or through 1998. That's 0.17 degrees C per decade in the surface record, 0.14 degrees in the satellite record, and if you reduce the satellite record to the surface, about 0.11 or something like that. That warming, if that were to continue, and it followed the linear behavior that we see in the mid-range climate models, would imply a sensitivity far less than is in the models. Why would that dissuade you if we were on a warming trend that implied a sensitivity that's far less? I don't understand.
Pat, that's an excellent question, and it shows why you should have been part of the debate.
I just wanted to point out that your answer was on tape, so you might want to adjust it.
Thank you. I have a chance to save myself. Pat is totally correct. And that's the trouble with this kind of question, is there is no point at which you would completely change your mind in science. There's evidence on one side, there's evidence on the other. Let me just say that if warming continues and it doesn't stop, I'm going to be more and more believing that humans have an impact on climate, which I think I believe anyway, no matter what. I mean, trees have an impact on climate. Everything that lives on the earth has an impact on climate, okay? But Pat is totally right. If warming resumes at the rate that it was, the numbers say that that's low climate sensitivity, and it may not be anything to worry about anyway. Thank you for correcting me on that, Pat. Good job. That shows why you're the elder statesman of this. Emphasis on the elder.
Yeah, hi. I don't believe that you draw enough of a distinction between the amount of water vapor that's in the atmosphere, or the greenhouse envelope, as compared to the amount of man-made CO2. From what I see, the ratio is something like, for every 10,000 parts of water vapor that you have 12 parts of man-made CO2. So how can we assign much of any importance to the warming possibilities of man-made CO2 when it's a trace gas compared to the overwhelmingly predominant water vapor that is in the atmosphere?
I understand where you're coming from. One thing I have to remind people is, even though Al Gore says we're dumping 90 million tons of CO2 into the atmosphere every day globally, as if the atmosphere was an open sewer, that it takes 5 years of doing that in order for all of humanity to increase the CO2 content of the atmosphere by 1 molecule per 10,000 molecules of atmosphere. There's very little CO2 in the atmosphere. It takes a long time to add to it, but we are adding to it. To answer your question, you have to do the radiative transfer calculations, and this is where Scott and I will agree.
Or the measurements.
Well, now, okay, I'll address that in a second.
Well, I mean, you can use models if you want, but you could do observations are good.
All right. It could be that Scott doesn't understand something. That 4 watts per square meter that he's talking about that will heat the climate system from a doubling of CO2, that is a theoretical measurement. There is no way to measure that from space. I know, because I'm involved with the scientists on the same satellite that have the instruments that measure this. We cannot measure the radiative budget of the Earth to that level of accuracy. That 4 watts is entirely theoretically calculated. Now, it has a lot of validation. What I like to use is that for decades, NASA has been flying satellites that measure at different infrared wavelengths. Remember, Scott mentioned That's how the Earth cools to space, is infrared radiation, and this occurs at certain infrared wavelengths. And we've got instruments up there that measure at thousands of individual wavelengths. And we can see the ones where CO2 is blocking radiation from escaping to space, other ones where the CO2 doesn't block radiation. And it validates the theory. I mean, if there wasn't a greenhouse effect, we wouldn't be able to measure the temperature profile of the atmosphere from space. In fact, if you look at it, if there wasn't a greenhouse effect, we wouldn't have weather, because the greenhouse effect is what destabilizes the atmosphere and causes convection and rain and everything that we know of as weather. So getting around to the original question. Yes, water vapor is by far the most important greenhouse gas. And in fact, I think it's entirely possible that there are natural changes in water vapor that can force climate. Everyone just assumes that doesn't happen. Scott mentioned, you warm things up, you increase more water vapor. Well, guess what? The amount of water vapor in the atmosphere isn't determined by how fast water vapor evaporates from the surface. Because you can't keep pumping water vapor into the atmosphere. There has to be an equal amount coming out all the time. That's precipitation. What controls precipitation? We don't know. All right? It could be that precipitation efficiency goes up with temperature, and in fact, there isn't any positive water vapor feedback. And this is actually, there's data to support that. There's the radiosonde data since the 1950s, which suggests that there has been a cooling of the upper atmosphere, a drying, less water vapor in the upper atmosphere at the same time that there has been an increase in water vapor in the lower atmosphere. And since the upper atmosphere is the most important for water vapor feedback, it could be that's negative water vapor feedback. Also, this whole hotspot thing, the debate about the fact that there hasn't been as much warming.
Roy,
I'm sorry.
15 seconds.
15 seconds. Am I past that yet?
Scott's itching to speak.
Okay, the lack of the hot spot in the atmosphere in our satellite data is also consistent with a lack of positive water vapor feedback. Gee, now I forgot the original question.
The original question, if I remember, was how do we know that CO2 emits this heat and it's not just water vapor? Isn't that what your question was? Because there's more water vapor. Go ahead. Oh, okay, so we had a 10-minute answer on that.
Yeah,
and
you have to run the numbers.
And I think that's my answer too. You have to run the numbers. You need to do some measurements.
Well, unfortunately, people that do that usually start from a point of 0 CO2, and that's irrelevant to the debate. We started at a level of 270.
But it's a quantitative question.
Yeah, it's a quantitative
and it has
thing.
a quantitative answer. I mean,
Yeah,
I think this is a reasonable
all
thing.
of the IPCC models can be faulted on many things, but it only takes one thing for them to be wrong on, in general, for the whole house of cards of dangerous global warming to collapse. This is not one of the Achilles heels of the climate models. Scott and I both believe that they have the infrared theory, the effect of CO2 in the infrared, basically correct, because there is so much evidence to support it, both from satellite instruments and from measurements in the laboratory.
Next question, please.
My question's for Dr. Denning. I've got 23 years in power generation. 2 years ago, the average megawatt price in June was roughly $85 a megawatt. In June of this year, it's been about $30 a megawatt at peak. We're dropping load every night in the middle of the summer. Part of that is because of the roaring comeback of the economy that NBC is always reporting on. So GDP is part of it, but another part of it is there were 6,000 megawatts of federally subsidized wind power on the grid last month that wasn't there 2 years ago. That's subsidized by money borrowed from China. What are the capital expenditures? What do you foresee as a capital cost of replacing all these horrible coal plants like the one I work at with things like nuclear in the short term, because we're not there infrastructure-wise. It's going to create a huge capital expenditure that you're going to pay for every time you turn your lights on.
So I'm an atmospheric scientist, and I probably am not the guy to really address the cost-benefit analyses of billions of dollars of infrastructure investment. But I will say that let's turn it around and say, what is the cost? What is the cost of building 2 gigawatt power plants in China every week for the next 50 years? It's a large number. I don't know what that number is, but it's big.
You mean in the number of Chinese lives it saves?
I hope that that's a large number.
All right, next question.
But as a cost, it's a very large number. And I want to just come to something that Roy said. I don't favor the government trying to solve this, because the government can't possibly solve this any more than it solved the last problem. What we're going to have is the free market solving this.
Next question.
To Scott, and it has to do with radiation in the atmosphere and all those dancing molecules
Yes.
that you've been showing. You somehow assumed implicitly that the forcing will increase linearly with the increase in CO2 concentration.
No, I
But
said
in
4
fact-
watts per doubling.
But in fact,
That's not linear.
In fact, it is not linear.
It's logarithmic.
It is, and how do you know it is logarithmic? Which means it'll saturate.
Right.
How do you know that we're not at the saturation point now?
Due to measurements.
Could you explain that?
Certainly.
What measurements?
You can measure the CO2, the absorption and emission by CO2 molecules in a laboratory in a spectrograph by running infrared light through the gas.
But at what pressure?
At whatever pressure you choose to put into the measurement.
It has to do with the line
And you can
width,
measure
the width of the line.
Precisely so. You can measure the width of the lines as it varies with increasing CO2. It's quite a straightforward measure, and it's been over 100 years that this has been well known.
We'll have to talk about
Well,
that.
Fred, it's the pressure broadening. As you go down through the atmosphere, the effect of CO2 affects more and more infrared wavelengths. And the very fact that we measure from space and can see frequencies, infrared frequencies, where it's not saturated, it validates all the theory. It's not saturated yet because of pressure broadening, and as you add more CO2, it's going to become more saturated. Yes, it's approaching saturation, but the devil's in the details, the numbers.
Agreed.
Thank you so much. That'll be the end of questions. One more round of applause for our speakers. And just to conclude, I think it's absolutely fantastic that we can have this dialogue. I know sometimes trying to keep them in with the questions and the topics is like trying to cage 2 lions. But the fact is, we can have sharp disagreements. We can certainly really explore any perceived fallacies of each other's arguments, and we should be able to do so. We should be able to do so with cordiality, with professionalism, and I commend the 2 speakers, Dr. Denning, Dr. Spencer, for doing so. And I hope we can have more of this, whether it's here through our Heartland Institute conferences, whether it's through, name your environmental activist group, name whatever group it is. I think we really need to come together and explore the science, discuss the science, and that is how we're going to get a better understanding of the issues. We will be reconvening in approximately 14 minutes, 2:15, back at the Thurgood Marshall Room. So now you're on break. Thank you very much.